Hello guys, let's welcome to our channel Just Genius. In the last tutorial, I have discussed about introduction to the data structures and given introduction to the data structures and also some basic definitions like what is data. In the last tutorial, I said in this tutorial I am going to discuss static versus dynamic data structures, as well as in this tutorial I am going to discuss difference between static and dynamic data structures. Okay, before going to static and dynamic data structures, once again we look into the classifications of the data structures. If you want brief classification of the data structures, you can watch previous video which is in the playlist. So let us start our video now. So now let us start the classification of the data structures first. Now here DC means data structure, DS means data structures. Now mainly we know that data structures are classified in two types. One is primitive data structures, another one is non-primitive data structures. Whereas these primitive data structures further classified in these data structures are called primitive data structures. These are I said you already, these are inbuilt data structures. So these are primitive data structures. Why these are inbuilt data structures? You daily use when you write, when you take in your compiler. When you take in your compiler, suppose you will directly write like this: int a equal to 10. Yeah, no, you are going to say this integer is in data type. What is a data type? That is an integer data type. This int is a data type of integer. This integer is a data type of primitive data structures. This is nothing but a primitive data structure. You directly use, those are called inbuilt. Okay, these are called inbuilt. Now when we come to the non-primitive data structures, if you see here, when we come to the non-primitive data structures, these are classified into two types, that is linear and non-linear. We have to know that about linear data structures. Here we got static and dynamic. In these data structures further classified into static and dynamic. You can see here static. Oh, not this one. This is stack and queue. You can see here static and dynamic. So linear data structures further classified into static and dynamic. Array is an example of static data structure, where linked list, this stack, queue, these three are examples of dynamic data structures. As I told in previous lecture also, I given these three examples in dynamic data structures, whereas array is an example of static data structures. Okay. Now, why array is an example of static data structures? Because if you take size of an array, now if I take size of an array equal to 10. Now here, if I take, I will show you. If I take size of an array as 10, size equals to 10. What is this size? Array size will be 10. Array comes under the data structure, static data structures. Why only the array comes under the static data structure? This is the main theme. If you listen, you maybe know it, but if the size of an array is 10, you take the size of an array is 10, but you cannot add more than 10 elements in array due to its size is 10. It comes overflow. In whereas in dynamic data structures, we can add more and more contents in the dynamic data structures. Like in the linked list, we can add front and back and middle. Like anywhere we can continue with this dynamic data structure, because we insert continuously elements. If you want to insert continuously element, then go with dynamic data structures. So that all programming languages also go with these dynamic data structures only. Okay. If you see here, this is the main difference between static and dynamic. Already I told you that the fixed size matters here. Fixed size matters between static and dynamic data structures. Fixed size. Okay. Whereas in dynamic data structures, it does not have any fixed size. No fixed size will be there. Whereas in static data structure, it will be fixed size, like array. No, with this. Okay. Now when you look here, string is an example of static data structure. Also string also having a fixed size, so it is an example of static data structures. So if you see second point, static data structures can neither grow if more memory capacity is needed, or nor shrink if capacity is unused. I will say about this point after the fourth point explanation is completed. Okay, I will explain about this point. Now if you see that, for this reason the programming language also provide dynamic data structures. If you understand this point, then you will be get to know what is this point. If you understand this point, you get to know what is this point. Okay, I am going to say explain about this point now. So if you see, dynamic data structures can expand or shrink using only as much of memory needed, because this is a memory. If we take dynamic data structures like linked list only, I will take only example as a linked list. We can add any elements continuously in linked list, but then its size will be expanded. No, as much as in the memory, it can be stored. So this is the main example of the dynamic data structures here. This point tells about that. Whereas in static data structure, if you see here, static data structures only capacity neither grow. You know, array, no, array, if you take array, the size of an array will be 10. No, you cannot add more than 10 elements. The size, it cannot be expand or cannot be shrink. Here is an, I given an example. See, this table is an example of this. Okay, now I hope that you have understood this lecture on static versus dynamic data structures. If you like this video, please like, share and subscribe. Thank you.